All right. So in this section, we'll learn about conditional statements. Let's see here. Let me give you the definition. So if P and Q are statement variables, the conditional of Q by P is written this way. If P then Q, or another way to say it, P implies Q and is symbolically or denoted P arrow Q. One second. So this statement, it is false when P is true and Q is false. Otherwise, it is true. So pretty much that type of conditional is always true. All right. So the one that we care about, that we usually try to look at, is when you have like a mathematical conditional statement, we care about the ones that are, if true, then true. And we try to prove those. And we try to find counterexamples for when it's true arrow false. Now, if you start an argument or a conditional statement with false, then it will always be true because it doesn't really make sense. So if you start with an argument with lies, then your argument will be true automatically because it's not based off, reality, I guess. So a quick truth table to give you an idea. So you have P, Q, P arrow Q. So it's always true if it starts off false. So let me write that better. So if it's if true, then true, the conditional statement will be true. If true, then false. That's the only time it is false. If you start with false statements, then the conditional will still be true. True. Okay, so we try to prove this guy, and we try to disprove this one, like in mathematics. This bottom one we try to avoid because it's not helpful. The book calls it true by default, so it's not interesting or useful. Okay. And like, for example, like check out this weirdo example in the book. If 0 is equal to 1, then 1 is equal to 2. You agree that this statement is false, right, P? 0 is not 1, obviously. So no matter what comes next, the entire thing becomes a true statement. But you see how that is nonsense? The way I like to think about it is like if you're in an argument with somebody and you bring fake information, then yeah, of course I'm going to be right, even though the idea is false, right? So that's kind of how I think about it. It's not a good way to, it's not useful, you know? Okay. So this is called a conditional statement. False hypothesis. So you want to avoid doing this. Okay. Does that make sense, or you see what I'm trying to say? So this is example 2.2.1. Let's see if I can fit it in better. So this is just like number 3 here. False arrow, false. Let's do another example. Let's do the truth table for the P or not Q. Implies not P. So we'll start trying to get comfortable with the conditional statement. Okay. And go. Create truth table for P or not Q. Arrow not. Let's write it over here. P or not Q. Arrow not P. So I want you to just try this out for a bit on your own. I'll start it off for you. P or not Q, arrow, not P. So I'm going to start you off here with the P's and Q's. So fill out the rest. Give me a couple minutes. 1 second, guys. Sorry. Okay. Sorry about that. So let's negate the P. Negate the Q. So true, true, false, false, true, false. So false, true. False, true into true, false. Both true. So now we're going to do the or statement with the negation of Q. So hopefully you guys got this. So P or not Q. So as long as one of them is true, we're good for the or statement, the injunction. True, true, doesn't matter. False or false. Well, there we go. False, false or true, true. So now we're going to do a conditional of this guy, these four right here with not P. So all we need is to remember, when is this false, right? We said only if it starts with true and ends with false. So true starts with true, ends with false. So this is the only time it is false. The rest will be true. I don't have to even think about it based on the definition. Okay, any questions on that example?
Wouldn't the second one also be false?
Let's see. P or not Q is true. If true, then not P. If true, then, oh yeah, you're right. Those turned out to be both. Thank you. Let's double check the rest. These combinations are not, are repeated possibilities. I didn't see that. Okay. So false or true, true or true, true or false. So those two of the same, it looks like. I see. Okay. Any other questions on number 2? So a lot of chapter 2 would just be messing with truth tables and trying to fill them out and figure out if that statement is true or false. And later we'll have like actual sentences and whatnot. Okay. So there's a note here. You can represent the conditional statement as of if then. If P then Q, that is logically equivalent to not P or Q. So sometimes that would be helpful. So switching, like kind of like a substitution. All right. So that'll be very, very helpful. Which will also mean that, so this will also be very helpful when we need to do the negation. So if you were to negate the conditional statement and you're like, well, how do I negate the arrow? Well, I can use the negation of this instead. Because this is something we've done before, right? So that would P and Q. P and not Q. Okay. So there's some formulas we can use later. So let's try to apply it to something. Let's see here. So let's change this example here. 2.2.4. Rewrite the following in if then form. If then form. Okay. So if, either, put this in English, either you get to work or work on time, sorry, or you're fired. It's usually true, right? Do too much. So changes to a conditional. So right now it's in not P or Q, right? So think of it as this right now. So you'd have to negate the P and then leave the Q alone. So the answer would be not, right? If I don't go to work or get to work on time. So if, or if you do not get to work on time. Then you are fired. You see how these are equivalent, right? Logically. Does everyone see how you can convert it?
Yes.
So all you got to do is look at the P and swap it to negation and changing it into if P then Q, and you'll be good. Okay. So basically, let not P be you get to work on time. just for more details in case it doesn't make sense. So P would be what I just said, right? You don't get to work on time. Does that help? Let me know if you have any questions. I'm going to move on to the next problem. Something doesn't make sense, please let me know. So negations of if-then statements. So now we're going to use the second part. Okay. So write the negation for each of the following statements. So if my car is in the shop, then I can't go to class. So what would be the negation using our formula up top, right? Using this guy. So we would need to use this. So what do you guys think? It's close, but we have to use the this formula here. So use the P and not Q. Right. So we would say, so we would negate this guy. Let me write some more steps for you. So we're going to assume that not P is well, the car is in the shop, right? For P. Q would be I can't go to class. So the answer would have to be use this formula here. P and not Q. So the answer would be my car is in the shop and I can't go to class. So whenever they ask for a negation of a conditional, you have to use this. Okay, that makes sense? So a negation of an if of a conditional if then statement does not start with if. Okay. Do one more just for fun. If Sarah lives in Athens, then she lives in Greece. So what is the answer? For the negation.
Would it be Sarah lives in Athens and she does not live in Greece?
Yeah, Sarah lives in Athens. That part stays the same, and then you negate the second part of the and statement. And she does not live in Greece. Okay, so that's it for negation. Let's move on to the contrapositive. Do you have any questions on those last two? Okay, keep going then. The contrapositive of a conditional statement of the form if P then Q is written this way. So the contrapositive of this guy is if not Q, then not P. So basically you just swap them and negate both sides. And that would be the contrapositive. They are logically equivalent to each other. So, so the contrapositive of P arrow Q is not Q arrow not P. And P arrow Q is logically equivalent to not Q, not P. Let's do one of these and move on. So writing the contrapositive, part A. If Howard can swim across a lake, then Howard can swim to the island. So the contrapositive would be, right? You just negate both sides and swap the P's and Q's, that's all.
So it'd just be if Howard cannot swim to the island, then Howard cannot swim across the lake.
That's it. So that would be equivalent to the original. Logically equivalent. All right. So does that make sense to everybody? So I'll move on to something else. Okay. Another definition. The converse and inverse of a conditional statement. So suppose a conditional statement of the form if P then Q is given, then number one, the converse is if Q then P. and 2. The inverse is if not P, then not Q. Symbolically would be just like this, right? Converse of P arrow Q is Q arrow P. 2, the inverse of P arrow Q is not P arrow not Q. And we'll do an example in just a second. Okay. Example 2.2.7. Right. The converse and inverse of the following. If today is Easter, then tomorrow is Monday. So what is the converse?
If tomorrow is Monday, then today is Easter.
Yeah, it's going to be if tomorrow, yeah. So we swipe it. Is Monday. Then today is Easter. Okay, and what's the inverse?
If today is Easter, then tomorrow is Monday. or sorry, if today is not Easter, then tomorrow is not Monday.
Yeah. If today is not Easter, then tomorrow is not Monday. So let me give you a quick note. P arrow Q is not logically equivalent to its converse. This just saves some time on writing. Not logic equivalent to its inverse. All right, another definition. If P and Q are statements, P only if Q, shoot, you know what? I forgot to write the name of the definition. Only if and the bijection. So if P and Q are statements, P only if Q means if not Q, then not P. Or equivalently, if P then Q, all right. Example 2.2.8. Converting only if to if then. So here's the example. John will break. John will break the world's record for the mile run only if he runs the mile in under 4 minutes. So there's a couple ways to write this. So we could say if John does not run the mile in under 4 minutes, then he will not break the world's record. So that's this first one, right? If not Q, then P. So that's the version that we used here. Okay. You could also say an alternate answer using the if then, right? If John breaks the world's record, then he will have run the mile in under 4 minutes. Okay. So on those questions, all I gotta do is convert it to one of these if then statements. It's up to you which one. Does that make any question on this one? Right. It's almost done with 2.2 then. Biconditional. So given statement variables, P and Q, the biconditional of P and Q is usually written this way. I'm sure you've seen this in the math books, right? P if and only if Q is denoted this way with a double arrow. So basically it's a conditional statement in both directions. You can write it in either way. Okay. both directions are true, I should say. So it is true if both P and Q have the same truth values and is false when P and Q have opposite truth values. Also, if and only if is equal to IFF. It's a shorthand. So here's the truth table for the double arrow. So true, 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 false, false, true, false, false. It's a double direction arrow. So we said it's only true when both are true. Otherwise, it is false. Okay. Here's the order of operations. For logical operators. So number one, the first thing you should always do is negation. Evaluate negations first. Number two, evaluate and oopsie, the and or statement second. If you have both in a problem, when both are present, parentheses, I forgot my hand there. Parentheses may be needed. Number three. Evaluate these third. And if you have both, same thing, right? use parentheses. Yes, that's right, true. Thank you. Yeah, it's in the definition. My bad. Okay. So you can always write the bijection, the biconditional as two sentences of conditional statements. So you could say, if P if and only Q, that means that you could say if P then Q, or Q then P. Let me double check. Actually, and, not or, and. Okay. Let me see if I have time to write one down. It doesn't look like it, but let me see.
I just remembered.
Mhm.
I tried to go to the cloud recording for yesterday and it didn't give me the option, or Monday, my bad.
No, I sent you a YouTube link.
Okay,
They're gonna be in
through
there.
like Canvas email or?
Yeah, Canvas inbox.
Okay, cool. Okay, thank you, my bad.
No, you're good. Okay, so let's do one last example and call it a day here. 2.2.9. I don't think I have time for the truth tables, but this computer is correct if and only if it produces correct answers. So you can rewrite this. So rewrite it is the problem, right? That's two conditional statements. So you could say if this, I'm gonna write PC, just shorten this up. If this PC is correct, then it produces correct answers. Okay, and if this PC produces correct answers, then it is correct. So both of these would be together. All right, so let me give you the homework for chapter 2.2. And I'm gonna create a section where you can upload it with the due date soon, hopefully tomorrow, if not tonight. One through 19 odd. 23. Twenty-three through 27. $34. Where is the bijection? Oh, here we go. So 32. 34. 37. That should be good. I guess we'll stop here. And I'll be posting that soon as well. Okay, so with the due dates. Guys have any questions?